don't need to watch too much of it. But the squid's completely dead, and the salt in the soy sauce is seeping into the suckers in the squid's tentacles, and it's triggering the muscles to then fire and go into tension, as if the squid were still alive. But there's no brain activity or anything going on there. It's just a chemical reaction. So I want to build that. Yeah. And I think that through this type of printing and through printing in the circuitry into a printed, if we print the rubber at the same time as we print the rubber as the substrate, and with the same printing head print the circuitry on the inside, and then we find I'm not an electrical engineer or this sort of thing, but we find a way to make one part of this thing go into tension, and another part of the thing relax, so that this piece of printed rubber with circuitry printed inside it will flex, and will flex in the same way that a muscle flexes, or will flex in the same way that the squid's tentacles flex. So I just made some little sketches to sort of kind of show the basic limits of what my understanding of how this thing might work would be. So here there's kind of a scissor lift sort of idea that if there's a mechanical system on the inside of this printed muscle, then that could flex in a certain way, or it occurred to me that we could use some sort of magnetic system of attraction to make one part of this synthetic muscle go into tension, and that's it. And I think that this sort of thing, if this is possible, if it's possible to then do this and use an electrical current to control a piece of printed material to flex in any direction that we want, then that would have wide-ranging applications in animatronics and things like that, as well as I would have a lot of fun making sculptures like that. But it could also be potentially revolutionary for prosthetics and this sort of thing. And yeah, I think there's applications beyond just what I'm getting at. So thank you. I hope that wasn't sort of too out there, and hopefully.